In this lesson, we're going to learn how to prove that two triangles are congruent to each other. Congruent triangles have the same shape and are the same size. So it's not necessarily enough to be the same shape. They have to be exactly the same size. And there are 4 ways that you can prove, given two triangles, that you can prove that they are congruent to each other. One of the fundamental theorems in geometry is that if you have two triangles and they have matching side lengths, those two triangles are the same size and shape. They are congruent. And the triangle on the right, the pink side of the triangle on the right is the same length as the pink side of the triangle on the left, and blue matches blue, and white matches white. So we can be sure, without a shadow of a doubt, those two triangles are exactly the same size and shape, and sure enough, they overlap each other. The second theorem to prove congruency is side angle side. And we have to have the side matching a side, and then another side, and then another side, and the included angle that they form. So it would be this angle here. And I want to demonstrate that once you establish the length of the green side, length of the blue side, green and blue, and when you connect the end point of green, end point of blue, and this angle is set, there's only one length that would actually fit there, and would be the length of this pink segment. So really this is a variation of side, 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 because once you get a side and an angle and another second side, when you connect them, that third side has to be congruent. So I'm going to try to rotate this right in here so you can see how it would work. So given blue matches green, the only way to get the third side connected is that it has to be exactly the same as the pink side. So side angle side is the second theorem. Next theorem is angle side angle. So if I start with a given angle, and I'm going to kind of focus on the shape of this blue angle here. I go that direction with one of the sides, but then I just want to form an angle. I'm just kind of eyeballing this here to make it about the same size as that blue angle. And then I have a side length about the same as this white side. And then I go with the size of the pink angle. And I've kind of already determined where this ray is going to go. And I've already determined where this blue ray or line segment is going to go. And as you continue, they're just going to intersect at this point. So given a certain angle size, and then a side, angle size, and then a side, same length as this one, and then the next angle, there's no choice but to intersect right at the same place. So by angle side angle, I can prove that triangle 1 and triangle 2 are congruent. So the third theorem is angle side angle. It has to be an angle and then an included side and then another angle. So the side that we're talking about has to be between the two given angles. It can't be an angle, angle, side. It's angle, side, angle. That order is important. Well, I should add, it can be angle, angle, side, because that's going to be the next theorem we look at. But if you're using angle, side, angle as your proof, you don't call it angle, angle, side. So the fourth theorem coming up in the next slide will be angle, angle, side. Okay, I'm just going to draw a couple of triangles here to prove the next theorem, or to demonstrate the next theorem. It's not going to really be a proof, it's going to be a demonstration. So I'm going to create an angle with 2 rays, and then just assuming, this is what's not a proof, that these two angles are congruent to each other. They're probably not exactly, but just for the purposes of what we're trying to demonstrate, assume they are. Then I'm going to put another angle right here, and say these two are congruent to each other, and say those sides are congruent. So then we have a triangle where we have, I'm going to just erase the extra stuff here so you can focus on the line segments of the triangle. And then by the proof of angle, angle, side, should be angle, angle, side, angle, angle, side. These two triangles are congruent. So that's the proof of angle, angle, side. One of the things that doesn't work is to say angle, angle, angle. So I've constructed to actually copy these two. They're exactly the same. Right now they are, but it's really easy to either enlarge or shrink the triangle. So obviously the angle size is not changing, but one triangle is way bigger than the other, are now way smaller than the other. So these triangles are similar to each other. So if you have angle, 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 you can prove the triangles are similar, which just means they're the same shape. They don't have to be the same size, but they're the same shape. So we can say about these that that angle and this angle match, maybe 90 degrees, maybe not. These match up, and the third angle are the same size. But you can't prove congruency. The other thing you can't prove congruency with is side-to-side angle. And you may remember this from past years where if you reverse the letters, you get a bad word that you can't say in math class, and you can't use it to prove two triangles are congruent to each other.